Hello DevOps friends, hey Potatoes, how you doing? Yeah, has it been a while? I did not stream on Tuesday because I didn't have the energy, but last week I think... Oh yeah, last week I was at DevOps Days Berlin. So yeah, it's been a while since I last streamed actually, yeah. And I'm happy to be back. It's Thursday. Time flies. The week is almost over already, and so much stuff to do. And it's actually so much stuff that I wasn't even able to pick something for today's stream. So we'll see what we're going to do. It's going to be a surprise as much for me as for you. So, but still, yeah, I'm back and happy to see all of you and do a nice little live stream on this Thursday afternoon. At the moment, I'm a little bit confused by some character set issues on my terminal that weren't there earlier. So let me see if that's a problem with this particular terminal emulator. What happens if we do this here? Nope, that seems to be a problem with the terminal emulator, actually. Okay, so let me log out here. We'll use Alacrity then. Okay, yeah, that looks much better. How are you doing, everyone? How's it going, Potatoes? I hope you're doing great. I'm very happy that my membership community, the server room, is starting off nicely with not only people joining the community, but also with our first few events going great. We did have a hangout, a casual chat on a video call earlier this week, which was a great thing because Tuesday was a little bit tough for me, and that's why I didn't do any stream. And but in the evening we did this hangout, and yeah, it was great to catch up with each other and simply have a chat. Next week we're going to do a hot seat. One of our community members has volunteered and asked for some feedback from me and the community, which we are going to do and give on another call next week. So I'm very much looking forward to that because that's going to be the first hot seat that I'm going to facilitate. And yeah, I hope and we'll all do our best to give our community member great feedback and stuff they can take away and stuff that helps them grow. And the week after that, which is I think going to be the last week this month, I'm going to do a deep dive, which is a session where I pick a specific topic and, well, present this in depth. It's basically a very thorough show and tell, and this time I'm simply going to present my Linux workstation setup here, explain why I did what I did, and of course everyone can weigh in and ask questions and discuss alternatives and things like that. Very much looking forward to that, and if you're interested in joining these events or simply have casual conversations and ask questions on our forum, then feel free to join our community at theserverroom.sh. Hello, Full Snarl, how you doing? Yeah, so this is going to be great fun, and I'm very excited to see all these things take off. Potatoes wrote, doing good, but pulling out what little hair I've left trying to figure out an issue with Greenbone, the vulnerability tool. Okay. Had never heard of Greenbone before, but that's because I'm not in SecOps or something like that, so I'm not surprised that I have gaps there. Furusnaba can finally see where they're going when they enter their apartment, which is also great. And you got a shader of the week. That's amazing. Feel free to post it in chat. So, yeah, what to do, let me see, I see. Interesting. Reflections. Okay. Let's see how this looks like. Copy link. Ooh, that's shiny. Nice. What happens if I pull this full screen? Okay. I like those reflections, these haze effects. They're very nice. And of course, all the reflections of the sphere in all these faces. Amazing. It's amazing what you can do. Not only what you can do with current hardware, because my machine doesn't even break a sweat doing anything here, but also what you can do with mathematics, because once more, I'm pretty sure, well, it is a longer piece of software, isn't it? But still, for me, it's still the same thing. I'm completely amazed what's possible with modern graphics hardware with relatively little effort. Contains 3 different kind of ray traces. I still remember starting up my Amiga and installing the juggler and looking at that. And that was only a readily rendered video of a ray tracing scene. And now we're doing it in real time. I'm sorry, I don't think I'll ever not be amazed by these things. I would say that shader of the week is definitely well deserved. You can adjust the shape. What do you... You don't mean I can grab one of these handles, can I? No, I can't. Oh, in line 5. Okay, line 5. What does line 5 do, though? Reducing the alias effects? Huh? Hmm? Line 15. Line 15. The poly V. So what happens if I make this 0.7? Huh. So that's... Uh-huh. 0.3. Yeah, that's the magic of maths, that you can simply change one of these parameters and that then changes sizes and shapes. And if I make this a larger number, 3 for example, need to make it 3.0, I guess. Look at that. Okay, interesting. Polytype. What happens if I make this a 4? It was 3 before, wasn't it? Uh-huh. Unreal. Let's take a look at these reflections. This is amazing. Look at that. Incredible. Thanks for sharing, Foods Novel. Amazing. We'll keep this running in the background here. I like it. Okay. What are we going to do? What to do? Maybe I need to get my brain going. And what better way to get the brain going than doing a round of words on stream? Let's start with that. Will you join me for a game of words on stream? Simply take the letters, turn them into words. Every letter can be only used once. Later, there will be a fake letter that can't be used, even though it's displayed. And once you've found a solution, you'll be locked for a while and you need to wait for the timeline to pass the next checkpoint. That's all the rules that you need. So, let's see how far we'll get. Simply post your solutions to the chat. Of course. As I said, I need to get my brain going first. It has to be at least 4 letters. We managed to get to the next level at least. Let's see how we fare on the next one. Hey Tiberian, thanks for joining in. Welcome. Come on, one more. You were probably still locked. Ah, nice. It was close, but we did it. That's all that counts. Ooh. Wow, okay. Great. You're doing great. We already have half of the points that we need. There are so many four-letter words. Wait, something's not right either. Yeah, the timeline got stuck. But we're almost out of time, apparently. Chugging coffee, welcome. Yeah, you're right. This is the strangest of combinations. And I guess that's it for us in this round. Anyway. A good first, I'd say. Okay. Let's see, what can I do? I mean, we could always go and work a little bit on my simulation game. If nothing else comes to mind, let's start with that. So, let's go to my simulation game. What was the name? I actually don't remember. Request animations, okay. So, what are we doing here? In this request animations repository, I have a Dragon Ruby game that I'm using to animate network traffic. I want to simulate network traffic between clients and servers and proxies and stuff like that. And so far, so good. We did already do a lot of stuff successfully. So let me demonstrate what's happening right now. So what you can see here on screen is a web client sending requests to a load balancer. And the load balancer then uses a round-robin algorithm to distribute these requests to the available hosts. At the moment, we have only one host. And as you can see, many of the incoming requests get dropped. These are these red requests that pop, get reflected here. And that's because our client here sends between every 10th tick and every 30th tick, something like that. And our client here requires 24 ticks to process a request. So if we send requests every 10 to 20 ticks, this client will not be able to handle them in time, and especially when these bursts come in, most of those get dropped. And I made this simulation already a little bit interactive by so I have the opportunity to add more nodes to the load balancer, which I'm going to do now. And unfortunately, this client here is one of the slowest that we can get. It takes 53 ticks to process a request, and that's of course also not great. From the animations, I would say I don't have my most up-to-date code on my workstation here. Let me make sure that's actually that's in my game, right? My game app. Already up to date. Wait a second. I remember having replaced these clocks with shrinking dots, though. Anyway, as you can see from these percentages here, that this server here on the left only has 55% success rate, and this one only has 42% success rate because it's only half as fast as this one, and this one is already overwhelmed. So we still see a lot of requests getting dropped. So let's add another host to the mix. Simply by virtue of the load balancer distributing stuff between these three nodes, none of which is really powerful, we get less dropped requests. So far, this one here is pretty good at 93%. This one's success rate will probably also rise over time. But yeah, things are getting better. Jackie Coffee says, do you have an intern? You can blame them. I think the intern in question is myself. I wonder, did I work on that during DevOps Days Berlin last week? If that's the case, then I still should have more up-to-date code on my laptop. So let me switch on my laptop and see, because yeah, it wouldn't make sense to work on outdated code, would it? Apparently I didn't push my changes if I made them actually, and I don't hallucinate everything. So yeah, that's how this simulation works at the moment. It's basically a visualization of how, in this case, a load balancer works. And I want to extend this to, for example, have incoming queues that get used by these servers so that they can receive more requests than at the moment when they are busy and have to drop requests. They can queue them internally and then process them, and just to be able to see how these different behaviors work. And then, of course, I'd like to be able to simulate different load balancing algorithms, like not only round robin, but also weighted round robin, for example, or other load-based or connection-based algorithms. And this is an actual simulation. It's not just animated. I'm using Dragon Ruby to build the whole animation. But if you take a look at the simulation or at the game itself here, I'm instantiating a simulation model here, and I'm creating a load balancer, which at this moment uses the round robin load balancer class, where I simply pass in a position and an empty array of receivers, and when I press the A key on my keyboard, then another receiver gets added to the load balancer, and the load balancer then starts distributing between more nodes. So if I go over here and press A, we get a fourth node, and we should see that almost all requests now are able to get handled. This 12 tick server here is really fast. It'll have a success rate of near 100%. Potatoes asks, did you do a blog post on this? It's way outside my area of expertise, but making simulation like this would boost my learning so much. I'm definitely going to do a blog post about it once it's a little bit more mature. I'm still also learning how to do these things. This was the first time that I even tried such a thing. I had to wrap my head around the whole way of thinking of the game development platform that I'm using here, Dragon Ruby, which is simply tick based. The game does a tick 60 times a second. It's fixed 60 FPS, and you have to do things based on ticks. If stuff has to be slower, you need to wait for a number of ticks and only then to do the next step and things like that. That was quite the challenge. It's a very different approach. It's basically a real-time approach to programming, where otherwise you would simply call stuff and stuff would happen at the speed of your program. So that was my first learning experience to doing this thing. Otherwise, once you have an object model or a class design that makes sense, things are getting really, really easy by simply adding a new receiver to our load balancer, and then since the load balancer only goes through them one by one and then starts over, I didn't have to add almost any code, and so yeah, this has been a lot of fun. And I'm not quite sure if I've already published the repository. At least not officially, but I'm pretty sure it's public already. I just need to find a name for that. I've changed that to... Let me check my laptop for a second. Because, yeah, I think the changes that I remember were changes I made last week while I was traveling. So, is this still named requests? No. Here it's named... is it even named? Yeah, it's named Dragon Ruby Network Visualization. Yeah, so this definitely has changed. What? My app? My game app? Yeah, this needs to be pushed. I was probably on a flight or something and wasn't able to push my changes. Okay, now we have an update, so let's shut this down and start from fresh. We'll start it from here. This still looks the same though. Interesting. Now this is really confusing. This is not identical. What's going wrong here? Wait. I did push this here. And I did pull this here. No, I did not pull this here. Interesting. Yeah, now we have the shrinking processing indicators here, which makes it a little bit easier to see when they're busy and when they're not. Okay, let me shut down my laptop again, so we don't drain the battery too much. Okay. So, I should be able to share the repository as well. Yeah, here we are. So that's the repository. Chugging Coffee says, oh cool, I picked up Dragon Ruby for free on one of the itch.io deals, but haven't used it yet. It was the same for me. I think I bought a license 3 years ago or something like that. Never touched it, apart from maybe a little test or something running one of the examples. And then I saw someone who built a JavaScript-based kind of this simulation, also for load balancers, and I thought, well, that is amazing. This is so great for visualizing stuff in my courses. For example, in my Varnish course, I want to visualize how Varnish receives requests, how it caches them, and then maybe sends the answer back automatically without even passing it on to the backend servers. Or if it doesn't have a cache content, then it needs to pass it on to the backend servers and then pass through the response from there. Visualizing that by hand or animating that by hand became really, really tedious quite quickly. And I thought there must be a better way. I can program. And so I saw that it's possible to program these things when I saw the JavaScript-based solution that someone else had. And then I realized I do have Dragon Ruby. Dragon Ruby is supposed to animate stuff. You can make bullets fly around the screen and then explode when they hit a wall or hit an enemy. Why can't I make requests fly across the screen and trigger some effect when they hit their destination server? So that's when I unzipped Dragon Ruby again and started going at it. And then it was simply a matter of building a proper object-oriented design here, where we use the correct classes for the right things. The model is, of course, the main class. Apologies, let me share my screen again. So here we have the model of our simulation. And for example, this model does not much more. That's in the simulation.rb. We need to extract those classes though into their own files. I think that's the first thing that I'm going to do today. That's a no-brainer. Refactoring. So here we have this model, and by default all this model does is it manages a number of entities, which it also initializes when the model starts. And mostly what it does is every tick go through these entities and call their own tick method. So the model itself doesn't really do anything. It's just a bunch of entities, and when the game does a tick, all these entities then do a tick too, thanks to the model. And it really depends on the entity what happens during that tick. And if, for example, we take a look at the different network classes that I've defined, for example, we have this random request emitter, which is basically this client that sends requests. And in its tick method, it renders itself and it spawns requests. At least it tries to. In order to render itself, it simply renders it calls the super method of its parent class, which is endpoint, and endpoints always render themselves as little squares. Hey Moo, how you doing? Welcome back. Good to talk to you again. We already had a call earlier this morning. So apart from rendering itself as an endpoint, it also adds this label which shows its minimum and maximum spawn rate. It's missing a new line here, and then we have the spawn request method that does the most heavy lifting. That is the actual core of what this entity does, and that's it creates a new request. If the spawn condition is met, then it simply creates a new request, which is also another entity. And the spawn condition is just a little formula that uses the minimum and maximum spawn rate and a little bit of randomization to send out these requests. And if you take a look at the request, for example, that's also really simple. The request is a sprite, namely a little blue square, and the main thing that a request does is it travels across the screen, and that's why this entity has a Vx and a Vy. So it has a X velocity and a Y velocity, one that gets the request to the receiver it's assigned to. So we simply calculate the path to the receiver that has been assigned to this request, and then it starts traveling. Because if an entity has a speed, then the entity itself, which is in simulation again, somewhere down here, In its tick method, it handles its time to live, which is another feature that I've built in. And then it does a move. And the move is simply, if we have an x velocity, then we move in the x direction. And we move in the y velocity. Then if we have one, then we move across the y-axis as well. And entities can always have a TTL, a time to live, and so that's the other thing that an entity can do. It handles its TTL. If we have a TTL assigned, then we decrement it until it's 0, and when it is 0, we remove it from our model because it's died. Which, for example, happens if it moves out of the bounds of our screen. So if the x position is negative or greater than 1280, then it dies, and this is a copy and paste error. It should, of course, be 720. So if our y position is negative or it's greater than 720, then it needs to die too, which we do by setting the TTL to 1. In the next tick, then it's going to die. Chugging Coffee asks, quick side question, are tick and render Dragon Ruby specific methods in this code example? Tick is, so I've picked the tick method from Dragon Ruby itself. Dragon Ruby itself simply offers you methods that you can call. It's not object-oriented, actually. You can build something object-oriented, of course, and that's what I did. If we go into our main.rb, then down here, wait, yeah, you can see here are a few methods that are not part of any class. The main thing that needs to be defined in a Dragon Ruby game is the tick method. And what I'm doing here is simply, if our tick count is 0, so we've just started the game, then I call the init method here, which I've defined myself, where we instantiate a new simulation model and assign that to Dragon Ruby's args state object, I guess, or yeah, whatever you could call that. And that way the model is instantiated and gets remembered from tick to tick, because the tick method in Dragon Ruby gets this args object passed as an argument. And then we simply grab our engine again out of the args state engine variable and call tick. And that's why I bridge from pure Dragon Ruby, which simply is called the tick method, to my whole object tree, you could say, starting with the model. That is the only thing that happens here, or starting with the engine. I called it engine. I guess it should be called model. So why not change this as well? At the moment, I'm reluctant to do commits based on specific changes. Maybe I should find... oh wait, that's Ghost script. I didn't want to do that. Maybe I should start trying to focus my commits here. What did we change by now? I just fixed the bug with our y coordinates, and then there was, I think, just a simple empty line that I inserted. So yeah, let's go ahead and commit this, fix max y is 720. That way we have committed this, and now I can actually do this refactoring. And speaking of refactoring, I think I'd like to try out RubyMine here. Instead of working in NeoVim, I'd like to see how RubyMine can make my life easier or not. So let's close this and go here. And there is a way to increase the zoom level for you. Let me see. Is that in editor? Oh, let's simply search for zoom, I guess. Appearance zoom IDE. That's... wait. Appearance zoom. Okay, let's go to 125. Let me know if that's okay on your screen. Hey, Exegete. Welcome to the stack. Good to have you. Yeah, I'm giving RubyMine a try, simply out of curiosity. So, what we wanted to do was... oh, it says Ruby version 304 not installed. Apparently it tries to use Ruby version 304. I had to delete my existing Ruby versions because I was struggling with Homebrew, actually. So I guess we should be able to get Ruby 304 back. Let's do that on the side. So let's actually get Alacrity back here. And let's do an rbn install 304. For whatever reason I had this installed, and so let's yeah, the build failed because of a zlib issue, I think, or this time it fails because of OpenSSL, actually. Oh, that's so tedious. Not sure why it failed, actually. Oops. Oh, okay. Just a second. Fatal error zlib.h. Yep. The zlib issue is a recurring theme here, and I think I can fix that by setting my configure options to Homebrew's zlib directory. So let's try this again. Still failed. I'm not fussed about that at the moment. That'll only eat a lot of time. Checking coffee, you're right. I could as well have simply increased the font size for my editor, but of course having the whole IDE zoom up makes it easier for you to see things, so I prefer simply increasing the zoom level here. Now, we wanted to make a little change that makes our terminology a little bit more consistent, and I'll do a refactor, rename. We'll rename engine to model. And that should do the trick. However, it seems to try a lot. What does it do here? Here? Oh, we interesting. So it'll rename that everywhere? Okay. Interesting. Let's see. Reference in code to instance variable engine. 9 references in 4 files. Here we have an untyped potential usage. That's in main.rb. That's exactly where I want to have this replaced, but then we also have a value read. In entity, where we are also using engine at the moment. I think let's do the refactor here. We can always see if this actually still works. So, how do I get my terminal back? Like this. And we'll call Dragon Ruby right from here. Okay, this still works. Okay. So we have a little bit more consistency in our naming now. And let's actually commit this to... How do I use this? How do I create a commit here? It's not immediately obvious how I do this. Git commit file. Okay. Icon under the file folder up top on the left is for commits. Oh, thanks for the hint. Does make sense. Here I have my changes, so I can actually select those. I already got a commit message here with my default message. Interesting. So that is chore. Use model instead of engine. That's a little bit too concrete, I think. Let's rename this. More consistent naming. Use model instead of engine. Let's commit this. Nice. All right. No Ruby interpreter configured for the project. Let's configure this. We have a Ruby 3.15 installed, so I'll simply select this. No? Do I have to select this? Apply. Okay. Good. Okay, so something that was nice is if I add another load balancer, you can see that a few of these requests go into the void because the receiver they were aimed at doesn't exist anymore at this location, and they won't change direction. How do I deal with adding a new host? So if in my model, which is in main, here we have the model, and if we press A, then we add a receiver. And what happens when I do that? I create a new receiver. I add it to the cluster that is there. This cluster is also a class that simply manages a bunch of endpoints. And we add a member here. And we add we assign the new member list to our load balancer's receivers, so that the load balancer actually knows that there is a new host that can receive requests. So I guess if we have a cluster, no, we have, interesting, okay, interesting situation here. Our model knows that there is a cluster. Our model, a cluster of servers here, which is this row of servers. We have a load balancer, and that's basically it. The model itself only learns about requests once our random request emitter down here starts spawning them. And the only way for our requests to be able to change course and find the receiver they were aimed at would be if every tick we actually adapt our trajectory. Let's see if that's actually possible. At the moment, our velocities get set only once when a request gets initialized. And what I'm trying here is that it always takes 60 ticks. That's not actually true. My formula here is wrong. I divide my the path that I need to travel by 60, which just means that's an arbitrary stepping here. It's a decent speed for what it is, actually. But I meant that the request always is going to take 60 ticks to arrive, which should be a different formula altogether. Exegete asked, have you played with your idea Vim config? I haven't tried Vim mode yet, actually. That's something that I'd like to do, yeah. If you have any tips for that, happy to take them. At the moment, I'm still using the default key bindings and stuff, just to see how it feels. And maybe as a little bit of a change of scenery in comparison to NeoVim. So, how would this have to look like? If it all should... Oh no, the formula is correct, isn't it? I take the whole distance that I need to travel and I divide it by 60, which means we'll have 60 steps to travel, and every tick is a step. So yeah, it'll take 60 ticks, aka 1 second, for our request to reach its destination. Okay. Exegete says there's a mode you could turn on where Idea Vim will tell you every action you do in RubyMine, so you can map them to keys. Oh, interesting. So it's basically a learning mode. Yeah, I'll give that a try. Oh, I'll have a look at that. Thanks for the link. I'm not doing it right now because I am already feeling pretty fried, which might also be because we have 25 degrees in my office here. It's basically summer in Ireland. It doesn't get much hotter than today. I think, what do we have? Let's see, my... Okay, yeah, it does get a little bit hotter. We only have 17 degrees outside. Maybe I should simply switch on the fan. Let's do that, actually. Get a little bit of fresh air. But 25 degrees, if it were 25 degrees outside, as it is inside my office, that would be pretty much the top temperature for the year, I'd assume. Not counting, not taking into... sorry, not taking into account climate change, so maybe we'll get higher temperatures in the near future. Chuggingcoff says, need to head out. Have a good rest of the stream. Yeah, thank you. Thanks for stopping by, and have a great rest of your day too. Alright, so... today is a little bit tough. I'll admit that. So, in order to allow the request to change trajectory, we would have to recalculate this. every tick, and we would have to track how far we've already come. So how much of that second basically is already over, which is easy because we could actually whoops. We could actually track the lifetime of an entity. That's something so basic that I think it makes sense to track that in the entity itself. And yes, now I think is the time to refactor our simulation classes here as well. So I'll create a new folder called simulation. And we'll move stuff in there. Simulation.rb needs to split up. That of course needs to be named model, but we'll actually remove that. That's the model. And we'll move that into a new file, model.rb. Yes, add it, please. Good. And of course, we'll need the frozen string literal comment. I need to create a snippet for that, because I'm so used to having a snippet in NeoVim that I actually don't remember how this needs to look like. Let's go back to simulation. Frozen string literal true. Okay. That's that. Now I've of course broken my game, so let's close that window anyway. And that leaves the entity class, which we'll actually grab with the frozen string literal comment. Okay, I can actually save that. So let's create a new file, entity.rb, and now I can finally find my stuff by file name. Why is there a second end here? That should actually not be the case, should it? Strange. Is one missing from the... Yeah, one is missing from the model class. That's that. So we have these two things, and that means we need our simulation.rb now needs to do the same thing that network.rb does, which is simply include all its pieces. So simulation rb, let's do the same thing, frozen string literal true, and then we'll require relative simulation model and require relative simulation entity, and I guess we'll also have to make sure that we have the namespacing correct. That's missing here, and that's actually what the end was about. This needs to be module simulation, and I'm sure I can auto format that, can't I? How do I do this? Find action, format, reformat file, Control Alt Shift L. Only changes whole file. Let's reformat the whole file. Yeah. Okay. And that actually shows that we are missing this end here. How about model? Here we have module simulation, and we are also doing this, so that looks good. And in the end, I simply need to include, yeah, I do require relative simulation and network, so our game should work again. Let's see if that's actually the case. Dragon Ruby, Yep, it does. Works as intended. All right. So let's commit this too, actually. Boom. That's basically a chore. Extract more classes into separate files. Boom. Yeah, that's nice. It's a little bit crammed here because I've increased the zoom level so much, but outside of my streams, it should be okay. Right, now what I wanted to do is give our entities not only a time to live, but actually an age. Yeah, it's not the lifetime, it's basically the age. And the age of our entity always gets initialized with 0. And I'd say we'll make this an accessor as well. Or let's be more precise here, let's make it a reader. I don't think we should be able to modify that from the outside, but age should be a method that we can call and find at the age of an entity, shouldn't we? And now, what we have to do is in our tick, we'll simply increase the age. We'll call it. Well, age would be, of course, the verb, but we'll call it increase age. That makes it pretty clear what's going to happen. So def increase age. Whoops. Need to be careful which keys I hit. Increase age means simply that we do an age plus equals 1, and it looks like we have AI-based auto-suggestions. This feels eerily like Copilot, even though I didn't enable anything inside the IDE, so that must have been put in there by default. Increase age. All right, now that all entities now track their age, we should be able to track the age of our request. And the age of our request, by definition, means how far it is on its path to its destination. And that again means that we can create a method. Let's see, somewhere down here, def calculate trajectory. And we'll simply move this down here. We could have actually simply taken this and used the refactor method. Let's do that. Refactor extract method. It's a private method which we'll call calculate trajectory. I hope it's going to be able to overwrite this. Method name clashes. Do you wish to continue? Yes, please. Can be replaced with a call to extract a method. Yep. Cool. Replace this occurrence? No, this will not. That's the actual definition. So here we have calc trajectory. This should still work as before. We've simply extracted that. So let's see if that's actually true. If I add another receiver, yeah, trajectories are still calculated, but as you can see, some of these requests that were underway went into nothingness. So we'll have now to not only calculate our trajectory when the request gets initialized, we'll also calculate it here in our tick. But that means at the moment we divide our remaining our remaining trajectory, or our remaining distance by 60, and that's why it gets exponentially slower until it actually finally reaches its destination. We could also have had the situation that it only approximates the target but never reaches it. So we'll have to fix this, of course, because now in calc trajectory we can't use 60 all the time. We'll use the age of our entity here. The age of our entity, yeah, we'll use 60 minus age. Age starts with 0, so our initial steps will be 60, but then what happened with this one? This one changed direction. I've never seen that before. Okay, things work as intended again. Are they a little bit faster now? No. I'm still not sure if this is actually a second of travel time here, but yeah, whatever. It does work. And that means... Wait, if we change the positions of our receivers... Oh, this should actually do the trick. Shouldn't they now... oh, that's why one of these changed trajectory, isn't it? Let's see what happens if I add another one. Boom. Yep. Just by magic, they changed direction and still reached their destination. Let's wait for a few more to get spawned here. Yeah, that's a nice little burst. Let's wait for another one. Here we go. Yep. Now, none of these requests get lost anymore. They automatically adapt. If the destination moves, the request adapts. So, yeah.
It's a Unix system. I know this.
It is a Unix system, and it is Silverwing. Welcome to the stack. Make yourselves comfortable. Happy to have you. Thanks for the follow. Now, that is nice. So maybe we should be able to also subtract receivers. Why not? What are we going to do if we subtract a receiver? We'll simply remove one of the array elements. Exegete, why so defensive? Okay, well, taking away a receiver would be naughty, because that means we now have requests in flight that can't actually get their receiver again. Well, I guess the receiver object would still exist in my code, and it's still tied to the request, so the request would probably go to where the receiver was seen last and then fly off. Interesting, yeah. But eventually we'll want to do that. So let's see. In main.rb we have our model here. Okay, so Add receiver creates a new one, and okay, we'll have to implement remove member from cluster, and then reset the receivers list in our load balancer. Okay, well, that's possible. Excuse me. I'm not at maximum performance today. Yeah, why not? Let's try this. What does a cluster have to do to... We already have a remove member function. Look at that. Someone already thought about this. Well then, let's go back to our main model here. So, what we'll have to do is remove receiver, where we actually we would have to get hold of one of these receivers though. Or we simply tell the cluster to remove one of its receivers. The model itself does not track these. Ah, interesting. It only has a cluster of servers here and a load balancer and the emitter. That's the very high level overview of our simulation here, and that's all the model cares about. Interesting. Okay. So remove receiver would simply call cluster remove member. And what would cluster do then? We would have to have a name here. That's for removing a specific member. Here I can pass in a member object and I can remove that. Maybe we should have another method that simply will be called shrink, where we delete add members. No, add members last ID. We'll take the last. Object in that array, get its ID, and remove it from the array. And if we use the ID, I could actually simply call remove member members last. Members last gives me the last object in this list, and then we call remove member and it'll delete that. It's a hash actually, so yeah, that makes even more sense. So yeah, we have a shrink method, which is... How is this how are these private methods, even though I can actually call them? Maybe that's because Dragon Ruby doesn't use current MRI Ruby, but mRuby. I shouldn't be able to call these private methods. They shouldn't be private methods in the first place, but that's something that I just remember, or that I just noticed. That's actually not okay. So let's make them public, which they apparently technically are already. So that will now allow me to call shrink on our cluster in here. I guess I should also make sure that my cluster even has members to begin with. So return if add members length equals 0. What's the issue here? Style numeric predicate. Ah, yes, that is .0. Alrighty. And I guess that's just white space we shouldn't have. Okay. Right. And now we can add the action here. Let's do this first in a quick and dirty way. If we press R for remove, then we'll call remove receiver. So does this work out of the box? If I press R, what happens? Boom, it breaks. Okay. Delete method missing on cluster. Method named delete with nil doesn't exist. That's in where? Cluster line 28. Wait, what? Cluster line 28 here. Delete members member.id. Oh, we are passing in an object. So yeah, that's actually the case here. But members last doesn't really work, does it? If members is a hash. Or is there a way? I mean, it doesn't bomb calling last on this hash, but it apparently is nil. Members is a hash. This is the ID. Members is just a single? No, wait. Not sure. Delete method missing on cluster. Why are we calling delete on cluster though? Wait, where is that? Cluster 28 in remove member? We are saying delete members member.id. And add members is a hash. Isn't that how this works with hashes? Am I wrong here? Ruby hash delete is a hash class method which deletes the key value pair. And I would actually call... Okay, I would call that on the hash. Alright, so my syntax is off. We'll call add members delete, and then we'll pass in member ID because we're using that as our hash key. That's fine. Okay, here we go. Yeah. There's something broken now because requests don't get dropped again. Oh, yes. Because we're fixing their trajectory. Yeah. We don't take into account that a request might be in the state that it got dropped, and which would mean it would go off to the sides, but due to our course correction, it'll still go in there, and then it'll die there. That's why it still changes its color to red, but of course our request can only calculate its trajectory if it is in not in the state dropped. So if it is in state dropped, then we don't recalculate that. Return unless, no, if at state equals dropped. Thank you. So that's that. Now they bounce off again, especially since we are sending a lot of stuff to a, albeit fast, but still overwhelmed backend server here. Let's add another one. That does work. Let's add another one. Oh, it's so nice that they take a curve and then still hit it. And now let's see what happens if I press R. How did we lose both of them? If you have 4, it always goes down to 1 again. That's strange. Oh, R is already taken. R means restart the simulation or restart the game, actually. Okay. So let's see. In main.rb, don't we even... Have we built that in? Yeah, key down R is reset. Okay. Well, let's reuse S for subtract. Add a receiver and subtract a receiver. So let's add a few more. That works. And if I press S, nothing happens. And all of them still get served. Maybe I need to actually restart my game for this to take effect. So add, boom, boom, subtract, nope, nothing. Works as before, and even if I add another one, we'll get 4. So for some reason, this does not work. Let's restart. No, subtract does not work. Interesting. Does it even get... Does it even get registered? Yeah, it does. I will call remove receiver, where we call add cluster shrink. And in shrink, let's see our member length here. Oh, phrasing. So what happens if I press S now? Yeah, that does not really shrink. Length is 4, so it should go past our guard clause. So we could actually put this behind this guard clause. Remove member at members last does not work. Let's add some debugging here. Removing something like this. That's nil. Interesting. What happens if I call inspect here? Member is nil. Members last does not work. So maybe I should educate myself about hash methods. Ruby hash. It would be easy with an array, but for some reason I chose a hash as my storage here. Yes, there is no first or last, which makes sense in a hash. Semantically, a hash is a random set of key value pairs. They don't have, by definition, don't have any order. So first and last doesn't really make sense. The question is, do I have to... I mean, I can always get the keys and then take the first of the keys and so on. What else can we do? Reject requires a... Use an enumerator? Yeah, okay, that's not what I want. What does select do? Spindles Gaming, thanks for the follow, I appreciate it. Welcome to the stack. That's also just a filter method, yeah. I should know these things, but my brain is pretty fried today, so I need to rely on my ability to relearn everything. Is there any method that I can abuse? Otherwise, we'll go the route using the keys. That's shift. What does shift do? Remove the first hash entry. That does what I wanted to do. I would rather remove the last one. But maybe that's also a way to get rid of a slow receiver by adding new ones at the back and removing old ones from here. That allows us to basically completely renew our set of receivers. So yeah, why not? Let's use shift for the time being. So what we'll do is add members, shift. I guess I can remove this and that. Now let's see what happens if we do this. We also need to redistribute our remaining members. Now let's see. If I press S, boom, nice. Ah, look at that. This does not really work anymore. Something goes wrong. How many do we still have? It looks like there's a phantom receiver over here. This one gets requests, this one gets requests, and then there's this one that also gets requests. Interesting. Here we have 3. This works if I subtract 1. There's this phantom thing here. And that doesn't get... Oh, now we have 2 phantom receivers of these? Interesting. Redistribute simply takes our servers and redistributes them horizontally. So, since this works, the redistribution works. Oh, yes, of course. We didn't update the load balancer. The load balancer still thinks there is something. And yeah, okay. Okay. So for the time being, what we need to do is just like here, where we add a member to the cluster and then also update the load balancer about the newly added member of our cluster. Of course, we also need to update it here. So let's reset this. And maybe we could couple cluster and load balancer, so that changes in the cluster automatically reflect in the load balancer. I'm not sure if this tight coupling does make sense, or if we want to be able to have this kind of disparity. But let's see if things work better though. Let's add a few more backends. This works. And if I subtract one, they get redistributed and the load balancer gets updated as well. Boom. Here we have now. Yeah, okay. So we removed a cluster member, but we still had a request in flight. And of course, this request couldn't find its destination anymore, and that made the simulation crash here. Which is interesting. Let's see where this happened. Yeah, that happened in request 68, where we recalculate. And at receiver is actually nil? How did at receiver get nil though? I can see why the request still thought it would have a destination, and that destination got taken off the screen because the whole cluster got updated and things like that. But should the request not still believe and have access to the receiver object? Because that receiver attribute gets set when we initialize the request. And from there on, it should actually exist. I think that's another instance where I need to take into account that I think the whole scenario gets recreated every tick. The whole scenario gets recreated every tick, doesn't it? No, it can't. It can't. And what happened to called trajectory though? Do we have... Oh, we have those twice. That doesn't really work. How does this even work? So yeah, let's add another one, and now let's subtract... What? Yeah, okay. The requests that are in flight, where do they even get tracked? They are tracked by the model, right? They get tracked by the model. As entities. I'm confused that this is possible to happen. A request that's already... Or maybe I'm reading this wrong. Oh, yes. That happens somewhere else. In request hit in line 43, here the intersect. Yeah. It's not. I didn't read this right. It's not the travel logic. It's the check if we have actually arrived at our destination. And in request 43, we are in hit. And how does it get called? Find usages. I guess what we're talking about is actually intersect. That's in model. That is not true. No, that's a... That's in entity. Yes. Not getting this. Here we intersect with an entity. That's model intersect. Here in tick we call intersect receiver if state is in transit. And intersect then calls model intersect. For our request and the other entity. Wait, what does this happen? In our request, so yeah, I'm still getting confused by the IDE a little bit. Here we try to intersect with our receiver if we are still in transit. Intersect receiver. then goes to entity intersect, and entity intersect then tells the model. Is there an intersection? Hey, Balthazar! Sorry for sleeping on your arrival. JetBrains, yeah, that is RubyMine. I'm trying out RubyMine just to see how it deserves its praise for its refactoring features and things like that. So far, so good. I do enjoy working it. It's still very unfamiliar to me because for example, I am struggling to keep track of which file I'm in at the moment. But other than that, that's fine. What does the notification here tell me? Set up Rubocorp. Display code offenses. Yeah, can we do that? Oh yeah, now it tries to use Ruby 304. Okay, let's close this again. Why is it even trying Ruby 304? Did I set a .rubyenv here? Ruby version. No, it didn't. Strange. I need to get my different Ruby versions under control. Otherwise, I'll switch to DevBox. This whole RBenv debacle with homebrew and stuff is getting on my nerves, so I might cut things short by using DevBox and use the power of Nix to get the Ruby version and the gems that I deserve. But let's try and track this issue down. We try to intersect ourselves with another entity, in this case the receiver, that as an object should still exist in our program, but it does not exist as an entity anymore. Now let's find out what model does. It tries to intersect two bounding boxes. Which it does. Load balancer RB19 in connect. Ah, I see. Spawn request gets called. Yeah. That's what happens is we have a request that, wait, that looks like a race condition. We get a request, that request comes in, and it connects to the load balancer. And now we're calling spawn request. And I think what happens is in spawn request, we create a new request with a receiver that's not there anymore. How is that possible? Wait. We call pick receiver, and in our drop-in load balancer, pick receiver will pick the next receiver. That seems to be nil. And so the request then gets a nil receiver and tries to calculate its trajectory there, and that of course doesn't work on a nil value. How does pick receiver get a nil value now? Let's see, round robin load balancer. If our receivers are empty, we don't do it at all. Otherwise, we are tracking at round robin. Interesting. So round robin has been increased to, or set to, the next receiver after the fact. And next time around, when we try to assign this or to get hold of this receiver, it's gone. Interesting, because receiver's length has shrunk in between. So what we need to do is we need to increment that before we assign a receiver, and in this case this whole thing becomes more concise. And now if we shrink our cluster, boom, a few requests go to Nirvana, but then the process resumes as intended. If we add a few more load balancers, that works too. And if we shrink again, nice. So yeah, we can now increase our cluster. Now you can see the round robin nicely. Boom, boom, boom. Fans out nicely. And now we can shrink again. Boom, boom. Which one are we losing? 25, 14, 54, 46. We've lost the first one, yeah. Okay. So let's add a few more. We'll lose the 14 if I shrink again, right? Yeah. And now we'll be left with 46, 54, 53. Yep. Okay, this does work. Frame rate warning, even though this is the active window. Are we trying to do too much stuff? No, that can't be it. Average FPS was 6. Does look like 6 FPS. It's actually quite fluid. Strange. Maybe that's a bogus message. Yep, but I like this. Okay, and we can get rid of that debug message here. Where does this even happen? Is it in our main? Wait, yeah, here. All right. Okay, we have added a new feature to our simulation. Now we can also remove receivers. What I'd like to do is I'd like to make things a little bit more generic, because the idea I had was I wanted to make this available to course participants in the first place, but basically all of you as well. And I thought, yeah, if I create a single game that contains all my simulations and maybe integrate a menu or something like that where you can then choose which simulation you'd like to run, I can simply go and release this as a free game on itch.io, and you could go there and run it without having to purchase Dragon Ruby yourself. And that way I could make this available in a working state, and not just the source code that's actually public on GitLab. For that to work, I will probably have to make things a little bit more generic, and just this thing here where my main model knows about these keystrokes or hotkeys is probably a little bit too specific here. This needs to be part of a specific simulation. So I guess what we're going to do is, since this model here is a specific model, namely, it's the model that in create load balancer creates a round-robin load balancer of all choices. It's the only option at the moment, though. This is also the round-robin load balancer model. And we'll have many models, I guess, between which we will then be able to switch. So, it makes sense that this model has these particular hotkeys. Probably we should also display some kind of help. So we need some kind of more generic hotkey management so that a model can register specific hotkeys and assign them to specific methods, and they get displayed on screen as some kind of a help caption or something. So that's going to be one of the next things, that we won't have a single model here in main, and instead we'll have a bunch of models. I guess that'll introduce a new model subfolder here, of which we can then pick and see which simulation we want to run. And each of these simulations will then have its particular set of hotkeys that change its behavior. That sounds like a nice idea for next time. But for now, I'm going to wrap things up. I think I'd rather enjoy the nice springy, if not almost summery weather outside a little bit, and get a little bit of rest. This has been a taxing week so far, for various reasons. Just one of the reasons, me not getting enough sleep. So, that's that. But this is still fun. I love this visual way of doing things. It's definitely a change of scenery compared to some Rails programming or things like that, or even infrastructure as code. It's just another way to use Ruby to have fun, and I'm very happy that I discovered this. So, I will commit this stuff. Let me do that right away, actually. So I can actually still share that. Let's see. In my commit window, can I get a hold of the changes? Yeah, nice. So there's now remove member and shrink with a fixed delete. Call here, entity, we've introduced the age. So maybe we should commit this separately. Let's say this gets committed as feature entities now. Age. Bam. So next, we have our cluster that can now remove members or shrink. We could even commit this separately too. Main use then remove receiver to actually do that. Okay, we could take this as well. Calc trajectory is new, that we've extracted that, and it gets called while our requests are on the way, so they can plot a new course. That's definitely a separate commit. Actually, that's also a feature. Requests can plot a new course. And in round robin load balancer, we have the fix for round robin being assigned to a receiver that has already been lost and will not be there next time around. So that is going to be a fix. We'll commit that fix after we've committed our change here. So that is a feature. Receivers can be removed. And finally, this is a fix. Assign next target. Or how do I phrase this? Let's see. Avoid round robin to target removed receiver. By assigning the next target in the previous is able to it was possible that this target had just been removed. At least that's my interpretation of things. Can't happen anymore, can it? Let's add a few. No. Let's remove those. Add a few more. Remove a few. Yeah, it did fix things. While I was writing the commit, I wasn't sure if I was interpreting things actually correctly, but I think I did. At least it looks like it. All right. That's that. And I think that's enough for today. I will be back tomorrow with my office hour. Niall Rain, hey, welcome. You're just joining us while I'm wrapping up the stream, unfortunately, but still. Yeah, tomorrow I'm going to do my office hour, and that's where you can ask questions and I try to answer them. So hopefully it'll be lots of questions about Linux system administration, Ruby coding, and other IT topics. I'm not that great at life advice, but I'll always make an effort to answer your questions as best I can. So yeah, we made some progress. It's becoming, our simulations are becoming more interactive. So let me just show you that. So to make it worth your while. We are starting out with our sender here, which sends bursts of requests to a load balancer, which then in turn passes them on to a server. Unfortunately, this server can't handle requests as quickly as they are coming in, so lots of them get dropped. Now I can use my keyboard to add more receivers. Oh, I'm sorry. Thanks for letting me know. So let's reset this. This was the initial state. We have a receiver that takes 51 ticks, which is very slow to process a request, and all other requests get rejected during that time. As you can see, most of them bounce off. We only have a 25% success rate, which is abysmal. So let's add a few more receivers. This one with 10 ticks is really fast, as you can see at its success rate. And so this cluster of 3 machines now is able to handle things much better. We can now, and that's new, that's what I've built today, we can now remove the first one as well. And so we only have our very fast one and another very slow one. So let's add another again, and as you can see, these requests all automatically get distributed to the available machines. So that's how things work at the moment. One of the goals, of course, will be to make things a little bit prettier, so not just have these ugly squares here, so things like that. But the simulation itself works very, very nicely. So let's subtract one again. Now we have 2 equally slow servers here, so these requests just can't be handled in time. Let's add 2 more. 47 is not great either, but now that we are distributing along 4 machines, that things are getting better. Let's add a few more. Now our success rates will be pretty high because finally the client down here can't send requests fast enough to overwhelm a cluster of 6 machines. And you can also nicely see the fan out of the round robin algorithm. So even these slow machines down here will have increasingly high success rate. Yeah, it's slowly crawling upwards. Yeah, and that's that. I'll build this out to a fully fledged suite of simulations with different load balancer algorithms and things like that. But yeah, and as I said, it's going to be a little bit prettier too. Having these squares as the requests is also not great. I'll replace that with another graphic as well. But that's for another day because, yeah, I'm pretty much spent and I'm now going to wrap things up. I think there should be... The green time animation is pretty satisfying. Yeah, I find that as well. Previously, I just had a green dial, a green kind of clock turning around, but seeing this shrink down and get slurped up, basically, is really nice in visualizing what's actually happening. So, yeah, I do like this. I'm using built-in sprites that came with Dragon Ruby, and so all these sprites have this white notch, which makes it easier to see at which angle they are pointing, and you can actually see that I'm actually rotating this sprite while it's shrinking. But of course this notch is a little bit confusing and it looks a little bit odd. And so by replacing these requests at least with plain blue squares and having these circles be without a notch as well, will already look a little bit cleaner. And it won't take a lot of work, I don't think. So let's see. We should be able to raid someone. I'm pretty sure, if I saw it correctly, Rachel came online just earlier. Black Glasses is also online with the Alt F4 stream. And yeah, who else is there? Shari makes art. Okay, great. Strangely enough, Rachel seems to be offline again. That must have been a very short stream. Or did I lose track of time? Yeah, let's go over to the Alt F4 and say hello. Alright, folks. Let's go and rate them. So, if you want, join me again tomorrow for my office hour at 1 p.m. UTC. And don't forget to also join our Discord if you aren't there yet. It's a nice bunch of people, which also applies to my new community, membership community called the Server Room, which is a great place to learn and to grow as an engineer, be it software development or system administration. And next week we're going to have our first hot seat on our community as well. One of our latest community members volunteered to get feedback on an assessment they did. And so I will interview them about it and give my feedback, and all the participants on the call will also. And I hope it'll be a win for everyone involved. And if you'd like to be part of this, join us at theserverroom.sh. And I'll line up our raid for Black Glasses over at the Alt F4 stream, and I hope to see you soon. Until then, take care.